Hello, I'm Awesome Tutor, and today we're going to be looking at binary. So, why do we use binary? Now, computers can only understand ones and zeros, and they represent voltage, on or off, or electricity or current. Write any of those in your exam, you'll get the mark. Computers cannot work with analog data, and analog data is continuous data and is represented in a physical way, represented in a physical media. And so we need digital data, which converts the analog data into separate discrete steps, and these are represented using binary digits, as shown here. Now, bits, nibbles, and bytes. One bit can either have a value of 1 or 0. So this is 1 bit, and this is 1 bit. And the bit is very small for representing data, so instead we use larger values, like a nibble. A nibble is 4 bits, like this, and a byte is 8 bits, like this. Now, an easy way to remember nibble and byte is a nibble is half a byte. Get it? Let's move on. A kilobyte is 1,024 bytes, and a megabyte is 1,024 kilobytes. We can also use gigabyte and terabyte. Gigabyte is 1,024 megabytes, a terabyte is 1,024 gigabytes. So the magic number here is 1,024. Remember that. 1,024. Binary digits. So here we have a binary number, 1 byte, 8 bits. And in binary, we use base 2. So here, the first digit is 0. 2 to the power of 0 is 1. So this 1 bit would be 1 in denary form, in the numbers that we use, because we use base 10. Now the next one, okay, forget the numbers forget the actual bits here. Just look at this and this. The next digit will be a 2 to the power of 1. Then the next will be 2 to the power of 2, 2 to the power of 3, 4, 5, 6, and 7. And that will give you these numbers. So each of these digits will represent each of these numbers. And if it is represented as a 1, then you count that number. If it is represented as a 0, then you don't count that number. I'll show you what I mean later. So 1 byte can represent numbers from 0 to 255. So if all of this was 0, then we'd have the number 0. If all of this was 1, then we would have the number 255. And you might be asked that in your exam. So binary to denary. State the denary representation of the binary number that. So the first thing I would do is this. Write the denary representation of each digit above each binary digit. So the first digit would be 2 to the power of 0, which is 1. The second digit, 2 to the power of 1, which is 2. The third digit, 2 to the power of 2, which is 4. The fourth digit, 2 to the power of 3, which is 8, and so on and so on and so on. And you notice that these numbers double. So yeah, that's an easier way to do it. Start with 1, then double, 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 double. Because we're using base 2 for binary. Now, as I said before, if the digit is represented as a 0, then we don't count that number. If it's represented as a 1, we count that number. So here we have the second digit, and that is 2. So we have 2. Next we have 8. The denary number 8 is represented by the binary digit 1 here. So we add 8. Then we have a 1 for 16. So we add 16. And a 1 for 32. And a 1 for 128. The zeros, we don't want those numbers. Those numbers will not count here. And add those up and you get 186. Now in your exam, you'll not be allowed a calculator because a calculator, some of them can actually convert to binary automatically. So you have to do mental maths. So let me give you an example and you try and do it yourself. Go, pause the video and try and do it yourself. Okay, so let's go through it. As I said, the first thing I would do is this. 2 to the power of 0 is 1, 2 to the power of 1 is 2, 2 to the power of 3 is 4, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, 2 to the power of 7 is 128. Here we have a digit 1, so we add 1. A digit 2, we add 2. a digit 1, we add 8, a digit 1, we add 64, a digit 1, we add 128. The zeros, forget them. So we get 203. Next, from denary to binary, which is a bit more complicated. So let's go through this example. State the binary representation of the denary number 91. Now with numbers as small as 7 or 8, it's kind of easy to convert denary to binary, because you can just guess your way through it. But with numbers as big as 91 or 125, it's harder. So let me give you a quicker way. The first thing we do is divide the number by 2, because binary is in base 2. So divide the number by 2, which gives us 45.5. And if it is a decimal, then our first digit is going to be a 1. Now we round this number down, not round it up, not round it to the nearest whole number, round it down, which gives us 45. Now 45 divided by 2 also gives us a decimal. And if it gives us a decimal, we round the next digit as 1. Round it down to 22. Divide 22 by 2, and we get 11. Now that is a whole number, not a decimal, so the next digit will be a 0. 11 divided by 2 gives us 5.5, which is a decimal, so 1. 5.5 rounded down gives us 5. Divide that by 2, we get 2.5. And that means the next digit is also a 1. Round 2.5 down, we get 2. Divide that by 2, we get 1, which is a whole number, so it's going to be a 0. 1 divided by 2 is 0.5. That's a decimal, so we get a 1. And then 0.5 rounds down to 0, and that's where we stop, because no matter how many times you divide 0 by 2, you're going to get 0. So we have a billion zeros after this. Now you're probably wondering whether you should add that extra 0 to make it one whole byte, or whether you should not, and just leave it as 1, 0, 1, 1, 0, 1, 1. Well, in my opinion, it doesn't really matter, because no matter how many zeros you add here, it will still be the same value. But just in case, for your exam, I would put that extra 0 to make it one byte. Because again, if you add, no matter how many zeros you have after the number, it's still going to be the same value. So you could add 1,000 zeros after this, and you'd still get the same number. So let's move to a question which you have to do now. So pause the video, have a go. Okay, let's go through it. So, divided by 2, we get a decimal, it's 1. Rounded down, divided by 2, we get a whole number, so it's 0. Divided by 2, we get a decimal, so we get 1. Rounded down, now we divide by 2 again, we get 7.5, which is a decimal, so we get 1. Rounded down, divide that by 2, we get a decimal, so it's 1. Rounded down, divide that by 2, we get another decimal, so it's another 1. Rounded down, and we divide that by 2, we get 0.5, and that is also a decimal. Round that down to 0, and well, you stop there. You could add an extra 0 if you wanted. I would do that just to be safe in the exam, but it doesn't really matter. So yeah, that's all you need to know for binary. Now you do also need to know how to convert from hexadecimal, and from binary to hexadecimal, and from denary to hexadecimal, and so on and so on and so on. But I'm not going to talk about hexadecimal numbers in this video, and if you really want me to, then leave a comment and I will do a video on that. Okay, so this has been the Awesome Tutor. Bye.